So our final graph, final log graph, we should kind of notice one thing here. That's that very you got to be very careful with that 1 minus x, just like we had to be careful with that 3 minus x when we graphed the exponential. All right, so the parent function, we're going to start off with that as log base 3 of x. Okay, so we should know by now that all logs, no matter what the base is, as long as the base is not 1 and positive, it's going to go right through 1, 0. Okay, so that's our initial graph, and then again, vertical asymptote is x equals 0. So what we're going to do is we're going to rewrite the argument. Okay, we're going to factor out a negative. Since I don't have much room here, I'm going to take 1 minus x. I'm going to write that as negative x plus 1, and then I'm going to factor out the negative, which means we have the opposite of x minus 1. If you distribute the minus sign, you'll get negative x plus 1, which you can switch it around and write it as 1 minus x. So all I'm doing is I'm rewriting the argument in a convenient way that helps me know what the transformations are. Okay, and it helps me apply the correct transformations is what I really should have said. So if you remember the way we described the transformation order, you always are going to reflect first, and you're going to reflect x and then y, and then you're going to shift, and you're going to shift x and y. So if you think about it, r comes before s, so we reflect before we shift. X comes before y, we reflect x before we reflect y, and then shift. Once we do that, we shift in the x direction and then the y direction. So if you just keep that order, then you're going to be a lot better off. So the first thing we're going to do is we're going to reflect about the y-axis, because when the negative is on the inside, we reflect about the y-axis. And so that's going to look like this. Reflecting about the y-axis. The y-axis is a mirror. Okay, so that right there, that's the graph of y equals, I shouldn't have written it there, but y equals log base 3 of the opposite of x. Okay, now because we have, the next thing we do is we're going to shift. We're going to shift in the x direction. So we're going to replace x in this equation here with x minus 1, right? So if we replace x with x minus 1, we go 1 to the right. So this little, follow the bouncing ball, we go 1 to the right, and then the plus 2 means we go 2 up. So we go right and up. So we go 1 to the right and 2 up. And because we just went 1 to the right, we also have to make sure that we move our vertical asymptote 1 to the right. So our asymptote is going to be x is equal to 1. And we're going to now draw the graph through this point. Again, we were lucky. We got another x-intercept, or y-intercept. So we have the y-intercept of 0, 2. And I'll show you how to find that later as well. So we have 0, 2 as the y-intercept. We have the graph going up. I mean, if you go from right to left, that is. So it's decreasing over the entire domain. But anyway, going up from the asymptote through that point and off to the left like that. But the domain then would be from left to right. So the lowest y would be negative infinity, the lowest x I mean, and the highest x would be 1, not including 1. The range for all log functions is always all real numbers. Now the x-intercept, let me use some space over here. Let me just show you the x-intercept so we have a nice clean slate. So if we want to find the x-intercept for this graph, we want to set the y equal to 0. We have log base 3 of 1 minus x and then plus 2. So we just set y equal to 0, because that's what happens at the x-intercept, is y is equal to 0. Now, we're going to move the 2 over because the log is sitting there by itself. The coefficient of the log is 1, so we want to keep it positive. And if we keep the log positive, it means we're going to have to move that 2. So we have negative 2 equals log base 3 of 1 minus x. And again, remember the Punnett square. We have a log equation, and we have the log by itself on one side and no log on the other side. So then all we have to do is just rewrite the log equation using exponents. 3 to the negative 2 is equal to the argument. and we have to solve for x here. So we're going to add x to both sides, and we're going to subtract 3 to the negative 2 from both sides. So could we write that differently? Sure. We could write that as 1 over 9, and 1 minus 1/9 is 8/9. 9/9 minus 1/9 is 8/9. So we can write it, that's about as clean as you can write it. So the x-intercept is 8/9, comma 0. And you want to do this. Make sure you just look at your graph and make sure that that x-intercept is consistent with the way you drew your graph. And absolutely it's consistent, because 0, 0 is right here, and 8/9, I mean, it's tough to get 8/9 exactly, but that's definitely some support for the way we drew the graph. And then finally we want to find our y-intercept. And let me scoot the paper up a little bit, and we can find the y-intercept by letting x equals 0. So we have y equals log base 3 of x equals 0. Now if x equals 0, we have 1 minus 0, which is 1. And then we also have to add that 2. Now again, log of 1 is always 0. So log base 3 of 1 is 0, because 3 to the 0 is 1. So that just goes to 0, and we have 0 plus 2, or 2. And we already knew that about that y-intercept. So again, that confirms algebraically what we found when we graphed the function. All right, last video, I think.